Columbia, Houston on air-to-ground 1.
Go ahead.
Go ahead, over.
Roger, John, we've gotten a fast shutdown. We need you to recycle the fast.
Okay. Fast is recycled.
Okay, we see it, John.
Coming down. Houston, we got our Spec 210 coupler fail in the experiment D.
Roger, John, we got the message here and we're looking at it.
Okay, it re-opt okay though. What happened was item 34 on Spec 211 went and opted itself to an item 35, and then when we redid it, it opted okay.
Okay, John, we copy.
Okay, and we got the good old water side pump cycle when we redid the fest. There it goes.
Roger that, John.
And Space Lab, this is Marshal Operations for Ulf.
Yeah.
Space Lab Marshal, we'd like to get some real time of whatever you're set up for. We recognize you may be running a little bit behind, but if it's okay with you guys, we'd like to flow some video. Space Lab Marshal, recognize you guys might be running a little bit behind.
Stand by.
We'd like to flow some real-time video if it's okay with you guys, even though you might not be right where we'd like to see you.
We are waiting. We are running a large frame on the mapping camera.
Okay, thank you. Okay, thank you.
Space Lab Marshal, you've got AV1 as much as you need for the 33 deactivation.
It's already set. Marshal out.
Go ahead, Ulf.
Okay, we terminated the metric camera. Remove it.
We copy that you're complete with the metric camera photography.
Okay, we took approximately the 70 frames Wubo told us we could take.
you very much, Ulf. Your go for 033 stowage at this point. And we would like you to cover the removal of the camera from the SWAA using video. And you may use all the tape that you want. A tape is available for your use on VITR number 1.
Roger.
Space Lab, this is Marshal Operations for any of the guys on board.
Hi, Mike.
Yes, Wubo and I are preparing to leave for Dryden, and we'll see you guys when you land.
Okay, bring a couple of six-packs.
Okay, 2 six-packs coming up.
And Space Lab, if you can spend a little more money, we can take care of some champagne out there.
Okay.
Go ahead, Madrid. It's you got a loud background squeal there because the ATC channel is competing with you this morning. It's just a lot of noise because of the air traffic control system that's working this freak too. .302 at Indian Ocean. clear, Houston.
Space
Okay,
Lab
we
Mark.
have 144E, 145 Charlie, 140, 46, and 149A.
Space Lab Marshall, this is the point where
Okay,
we normally would be flowing video from
149A,
25. Understand you guys might not be
146,
quite there yet. So
145C,
if that's the case, we'll go outside with camera B.
144E.
Otherwise, if you can support the 25 at this time, give us a go ahead.
and the one that we gave MS is on the south. Loud and clear, Houston. Charlie. Okay, we got that one. We got the one for the SAL. We already gave it to the mission specialist, so we didn't keep the number. Okay, 032 Charlie is reported to be back in the space lab. Say again, over. We have no yellow light, we have no red stripe, so we must have more than 30 feet of paper on the tape recorder.
Okay, I'm just going to shut this. We'll zoom this one back out and we'll shut her down here.
2356 at Goldstone.
And Space Lab Marshal Ops, we have you for 52 minutes through TDRS.
Yeah, Marshal, this is Space Lab.
Good evening, Ulf. And Space Lab, is Bob close by?
I think he's in the mid-deck at the present time.
Okay, I need him to give me a call before he goes to bed, if he hadn't already gone to bed.
Okay, I'll let him know. I should be informed that we are running both video cameras and we record both of them, and I'm here, but we had a little system problem and I had to wait for Bob to get the 104 experiment done.
Okay, we copy that, Ulf.
My understanding was that the video was meant to be real time, but anyway, I have it on the recorders right now.
Okay, we'll let you know if that changes.
POCC Space Lab, you calling?
Yes, good morning, Bob, or good evening, whichever it is.
Good evening.
Bob, we need you to go to the R7 panel and do a 02 mal 2.22.
Stand by on that. I can't hear you. Okay, now say that again.
Okay, we need you to go to the R7 panel and do a 02 mal 2.22.
I'm clear, Franco. Okay, what do you need done on R7?
That's a 02 mal 2.22.
Tell me what that is. I don't have that procedure with me, and I'm up at R7.
Stand by, Bob. I don't know what it is either. We just got it in the handover. Okay, that's the emergency shutdown. So on the page number is 02 mal-20. I can read it to you if you want me to. And Bob, what we want you to do is just block 6 on that page for that mal.
Okay, I'll check into it and call you back.
All that
about
is
15, 20 minutes.
All that is, Bob, is hold the CPAC battery disconnect for 5 seconds.
Yeah, they did that downstairs, and they already show 0. Why don't you ask somebody why we got to do these things 18 times?
Okay, Bob, we apologize. If the first part of it has been done. There's two sides on the page here. And the other one, we want you to return the CPAC battery to connect. Okay, Space Lab for Bob. The concern here, Bob, is that because of the Route 21 problems, we think that there's a possibility that some of the CPAC safing that we had planned pre-mission hasn't worked, and that's a concern for having you do this at this time.
Okay, I'll call you back in a bit.
Okay, thank you, Bob.
Okay, Madrid in 15 minutes. Okay, Franklin, have a good evening, over. Morning.
Okay, good night to you, John.
Hey, partner. Can you read me?
Yeah, I read you.
It's your turn.
Thank you.
Oslo?
Go ahead, Ulf.
Yeah, be advised, I'm done with the ball game and I turned the recorders further.
You're a little bit broken up on that transmission, Ulf. Can you repeat that?
Sure. I'm done with Helen Ross's ball game, and I turned both VITRs off. We have on one just 7 minutes. No, wait a minute. On VTR2 there are only 4 minutes left, and on VTR1 there are 21 minutes left. If you want me to change the tape, I'm happy to do it.
Yeah, okay, thank you very much, Ulf. What did you put on VTR number 2?
On VTR number 2 was camera 2. That is the one which looks from above into the workbench area and observes the motions of the left hand. I think that is probably for the PI. And on VTR1 was camera 1, which looks into the workbench area more in general, and that is probably more PAO type of video. Shows the test subject standing there.
Okay, and we thank you, and DMC thanks you.
I did that because Chuck advised me that Alan Ross wants to get that on video, but we were running late due to this computer problem we had.
Okay, we understand, Ulf, and that's real good. Could you tell me what the status is on the 33 stowage? Is it complete?
Yeah, that's complete.
Okay. And
We did everything. Tell you what, I mean, I'll give you a brief summary. I did some FPM stuff, and Bob ran CPAC most of the time, and then we came to FO4 of experiment 102, and stowed the metric camera, did also 104, the Hoffman effect, electroshock experiment, and I did the ball game, and well, now I'm basically done for today. I do heat legs.
Okay, we copy, Ulf, and have a good night's sleep.
Okay, well, we'll be around for a little while. Thank you.
Okay, fine. And Space Lab from Marshall Ops, the PAO people, thank you, and the TV Ops people, thank you for the TV-23, and the 104 people pass up their thanks for getting another run for them, and Helen Ross thanks you for another run on 25, and what is the status on 322?
Let me check. You forgot your mother, Bill.
She also sends her thanks, and my wife Patty and my children Ashley and Jennifer and Christopher say thanks too, Bob.
Can't be working hard enough if they have time to talk to you.
Well, I really enjoy it.
Okay, on the... Go ahead.
Go ahead, Ulf.
Okay, I'm standing in front of the 322 panel. First of all lights are off. So that probably means that the experiment is turned down. Power light is off. And that is true for 322 and 333.
Okay, I think the critical thing, Ulf, is the cadmium standby.
Oh, that's experiment 324, I think. Oh, Bill, I was mistaken. You're right. 322 is cadmium telluride. Well, the mirror heating facility is shut down. The panel is closed and bolted down, ready for landing. And the sample is still inside.
Okay, thank you very much. And we do want you to leave that sample in for landing. I'm sure you understand.
Okay. Okay, be advised that I completed the 101 checklist, day 8. That is just to flip 3 switches. So 101 is deactivated.
Okay, Ulf, and take it easy, and Just go do what you want to. We've got everything in hand, I think.
Okay. Let's see, Space Lab.
Go ahead.
Okay, I now have the malfunction book.
Okay. We want you to do the right column, block 6.
All right, why are we doing all this when we also have done the regular one over there on DT-20?
Bob, I don't know. I'm just following instructions.
I'll follow instructions, of course, but I think it's a bunch of crap about a bunch of nothing.
Well, we'll note that in the log, and I agree, but we would still like to have you do block 6.
POCC Space Lab.
Go ahead, Space Lab.
Okay, I'm standing up here. I'm going to hold it to disconnect for 5 seconds.
Okay, we copy that.
Mark. I'm now returning it to connect. And I have notified the POC.
Bob, we sure thank you very much.
And next time I have them write all 3 procedures as a chain instead of on 3 separate procedures. If we've got to do all 3 of them.
We copy, Bob. Thank you very much.
POCC, we have a 19 alpha message.
Bob, a little bit garbled. Can you repeat that, please?
Roger, we have a 19 alpha message. I'm not sure. It just says crew alert 41, but there's no ECAS in there.
Just disregard that, Bob.
Yep, that's the kind I like.
And Space Lab, this is Marshal Operations for Byron, if he's handy.
Stand by.
And Byron...
Space Lab, PS2.
Go ahead.
Roger, we're on the comm loop. Go ahead.
Byron, the 101 PI would like to talk with you if you have a chance to copy.
Okay.
Space Lab 101 for Byron.
Roger, 101. Read you loud and clear. Go ahead, over.
Hi, Byron. I'd like you to verify that OFF did in fact deactivate 101.
Okay, well, I see the mode switch and deact. The clock power's on, and that power's on. Everything else is off. To the extent
Okay, that confirms we're in deactivation mode. It should not be in that mode at this time. I would like to give you a few steps to bring it back up, if you don't mind.
Hey, go ahead. I'm right here at the panel.
Okay, would you switch the activate switch to off? Battery switch to off? Mode switch to normal? Did you copy?
Yeah, those are complete. Yes, those are complete. Go ahead.
Okay, power switch to on. Activate switch to on. Depress reset. Depress start.
Yeah, that's complete.
Depress HK data to verify the experiment is operating.
Okay, hold on. Looks like it's on and operating. Both rotor speeds are 0 because they're turned off. And the temperatures are good at 24.9er and Dark Fox 24.4, and I've got an HET time of 87 hours, 38 minutes, over.
That's very good, Byron. Now, I'd only like to ask you to do one more thing, and that would be to perform a tape change for the VTR that was supposed to have been done at this time period.
Okay.
Need I talk you through that, or do you know it by now?
No, I know it. I'm just trying to figure out here. It's tape number...
Tape number 5.
Has a footage counter reading of 769er.
Thank you.
Okay. Tape number 7 on it. I don't see a big number, any other big number, so that must be the one, huh?
Does it have a colored label on it?
There's no colored label on it. It says spare tape, test recording at 870 to 880.
That's it.
Hey, that'll be in. Hold on. Hey, for 101, the green tape 4 ended at footage count of 772.
I copy.
Okay, we're in record now. I've got a green pause light, and footage counter's reset to 0.
Thank you very much, Byron.
Hey, no sweat, Al. And you guys better tell us when you want us to go ahead and do the 101 deactivation because, well, maybe it's on Ulf's next shift. I'm not sure.
Yeah, it takes place about 12 hours from now. I'll make sure they get reminded.
Hey, yeah, it's not on our shift, so you have to tell them because I think Ulf thinks he's finished it. Marshal Ops, Space Lab here for the MSDR people.
Okay, stand by. I'll get him on the line.
Space Lab, this is 300 Ops. You had a question? Space Lab Byron, this is 300 Operations. You had a question?
Roger, yes, I did. On the ultra-high vacuum experiment, we still notice a stoplight and flashing ops. Do you guys want us to do the halt UHV 31 enter?
Stand by. Space Lab 300 Ops here.
Roger, go ahead, 300 Ops.
Yes, Byron, that's affirmative. We'd like you to do that halt UHV 31 enter.
Okay, Mel, welcome.
Thank you.
Space Lab, Houston, air to ground 1.
Oh, Houston, this is Space Lab. What do you say this morning?
Well, as I told John earlier, the Bronze team greets you, folks. This is the last time we're going to be talking to you, but congratulations on a superb mission.
It's Bill, isn't it?
Yes, it is, Owen.
We certainly have enjoyed working with you and the rest of your shift down there. Things have started off a little rocky in certain ways, but it's gotten better and better every day, and we're certainly been pleased with how things have gone up here, and we've enjoyed working with you all a lot.
Well, you guys have done a tremendous job. I know you're working hard, and you're looking forward to getting a little rest, but you've really done a super mission.
As a matter of fact, we'd be even more looking forward to another 10 days in orbit, but I don't think we got a chance to stay up here.
Yeah, I don't think consumables will let us do that, but I do have a note dealing with the ACS checkout, specifically teleprinter message 137 when you've got a chance.
Okay, I've got it posted on a board over here, a bulletin board, a clipboard, and if you'll let me float over there for a minute, I'll refer to it. Morning, Bill. Byron up here. You guys sound good down there today.
You guys are sounding good and looking good. We've had a chance to watch you a lot on the TV here, and you really seem to be moving around well.
We're having a lot of fun. I'm sure you'll really enjoy it when you get up here, too.
Well, I'm sure we will, Byron. Thank you.
Yeah, I have that message in front of me, Bill, so what was it you wanted to refer to?
Roger. To make it easy, I'll just tell you to delete lines 5 and 4 9er. Specifically...
Page.
Okay, Page, it's message 137. I believe 5 is on page 1.
It's 3 tape.
Okay, 5 is on page 1, and I'll check on the other.
Okay, line 5 on mine says obtain gray tape from storage. Is that what you want me to delete?
That's affirmative. And they're both
okay.
They're both on page 1, though. And what we're doing is we're not going to ask you to tape over any of those 6 holes on the vent line bleed valve. We just like you to delete that whole step procedure, and you can just cross out those lines and proceed as it's written otherwise.
Okay, what was the other line?
5 and 49, both on page 1.
Okay, that's fine. But wouldn't you know, we've already had the gray tape out. Can you imagine that?
Just like the rest of the mission, knowing you're way ahead of the timeline.
We were up at the aft flight deck window a few minutes ago, and Ulf noticed that floating about 4 feet behind the window in the payload bay was a very small washer, right floating along with the spacecraft. And it drifted out of view over a period of about 5 minutes. So we trust that things are not coming unbolted back there after 10 days, wouldn't you assume?
Roger, we trust so also, and if you see any more of those washers or bolts or anything like that, why don't you give us a call?
Go.
Okay, I'm going to go ahead and turn it back to Marshal Ops. We're about 30 seconds LOS to Tidris, and good luck to all of you.
Okay, fine. Thanks again, Bill.
And before you guys go over the hill, we would like to have a confirmation that the SWA window heaters are in the off position.
Well, the SWA window heater is still in the off position, and as isn't that what that Bob has reported on maybe 3 times before?
Well, yeah, we need to get confirmation on this shift that the safety cover's on, and I'm sure it has been, and we're sure that you verified that the outer cover is latched, but we need to hear those words one more time.
We're getting a little static in the other ear from Robert at that time. But I think I got it. Parker says to tell you that the SWA window heater came on when the CPAC battery switch went off, over.
We copy.
For the 3rd time.
Okay, guys.
I was just acting.
And Space Lab Marshall Ops, we've got you through Aurora Valley for a short pass.
Still loud and clear. WB4OQD, right?
That's a Roger, Owen.
Time we were through here, Aurora, I guess it was really a couple, 3 days ago, had a fantastic ham communication. They really went through a lot of work to get things set up well there. It worked as good as S-band or better.
That's just terrific. I'm glad to hear it, and I'm sure there are a lot of other people around the world are too. It's quite a first, Owen. And Owen, you did copy on my last transmission, didn't you?
Negative. We didn't hear anything except your call that we had a few minutes at Aurora.
I mean, before Aurora, the last transmission. Before we went LOS on the last pass.
I'm sorry, I don't remember any of it, Bill. What was it about?
Okay, we want you to, we want it verified that you have replaced the window on 33. That's the inner window on the SWA. And we're going LOS, and we'll see you in about 1 plus 20.
Roger, Bill.
And Space Lab, this is Marshall Ops. We have you for 6 minutes and 30 seconds through Hawaii.
Okay, Bill, we got a good copy on you.
And Space Lab, this is Marshall Ops. We have you for about 20 more seconds, and we'll see you in about 4 minutes through S-band.
Okay, Bill, copy.
Space Lab Martial Ops. We have you through TDRS for about 50 minutes.
Hey, Debbie, nice to hear from you, and that's fine. We'll be here.
Okay.
Morning, Debbie.
Good morning.
Weather in Houston today.
Repeat that, please. Weather in Houston is beautiful today.
It's good. It's beautiful up here also.
I bet.
Debbie, we were just cleaning things up a little bit back here in Space Lab, and one of the things that I've got in my hand is about a half a loaf of bread that we haven't finished yet, and on it is... I don't know, what about the first half of this loaf we've already eaten?
Owen, we lost you for a few minutes. We understand that you have about a half a loaf of bread up there, and what are your plans to do with it?
Well, I was just... can you hear me now?
Yes, we hear you now.
I was just reading the little tag that's on this half a loaf, and it says, you pay 99 cents, which I presume is the price that was that NASA had to pay to put it on board. And it also says, last sale date, November 25. As I recall, that was a week or so before we launched, and I'm just wondering if we shouldn't have eaten the first half of this loaf.
I think it's too late now, Owen.
I didn't make it sick, so it must have been good bread.
Just keep us posted.
Oh, Debbie, how are you?
Fine. How are you?
I'm very fine.
Oh, this is Ulf.
Looking forward to see you. Yeah, this is cool.
Ulf, you'll have to repeat that. You sort of cut out there.
Okay. See you in Huntsville.
Looking out at the pallet here, Debbie, it looks like ISO has one spectrometer window open and 23 has got its aperture open, so it's a fairly quick way to check what sort of automatic operations are underway, just to take a look at the pallet.
Okay, thank you.
And Space Lab, this is Marshall Ops. Are you people having trouble with the OFD display?
Negative, Bill. We haven't touched the keyboard for, I don't know, 30 minutes.
Okay, well, we're copying some messages down here on this event table, old Owen, and we're just wondering if you all were having some problems with it.
No, I do recall looking at it maybe 30 minutes ago, but we haven't touched it, I don't think, in that length of time.
Okay, fine, Owen.
We do have the task loaded, I see. We can toss it out. Would that make any difference?
No, I don't think so. I just disregard those, Owen.
Last message was an event table old at 17 hours 0 minutes, so that was 40 minutes ago.
Okay. Everything's cool. And, Owen, we're going to be doing some XTLM work, so if you get a few messages, just disregard them.
Okay.
And Space Lab Marshall Ops for Owen.
Go ahead, Bill.
Yeah, Owen, to make things a little bit easier here on this video tape recorder routing, we'd like to have all the orbiter activities on recorder 1 and all the Space Lab activities on recorder 2. And what we're going to do is configure that from the ground, and we'd like for you all to just manage that on orbit.
Okay, anything we need, we'll put orbiter on TR1 and Space Lab on TR2.
That's great, Owen. And Owen, if you have a chance, ISO would like to have you go up to the aft flight deck. I think you talked to the PI last night, and take some more pictures for them between 2:30 and 3+46 today. That's with the Nikon camera.
Okay, and they'd like to look along the -Z axis at the horizon again, I expect.
Yes, that's affirmative.
Okay.
Great. And Space Lab, this is Marshall Ops. Just to advise you that the last part of this pass may be a little bit iffy, and if we lose you the uplink, just be advised.
Okay, Bill.
And Space Lab, we may be out of comm, but we'll see you at 2+30. And Space Lab Marshal Ops, we have you for 3 minutes through Aurora.
Philly, loud and clear. Everything's going swell up here. You got anything for us?
Yes, we would like to dump tape recorder number 1, but we need an okay from the guys in the front because that's their recorder.
Recording on it?
Okay, we're going to do a rewind on it, and we want to dump it if that's okay for the guys in the front if they don't have anything to put on it, Byron.
I'm at VTR number 1. Are you talking about the orbiter cassette recorder?
We're talking about the VTR-1.
Hey, I don't think they've been using it at all. I don't think we've had anything routed down here whatsoever. Stand by. Oh, how do you read me?
Loud and clear?
Yeah.
Are you breaking up now?
Get up, Owen.
Byron, while Owen's getting up on the line, we'd like to have you set up a TV-21. Madame Rideau would like to try to get a run at 3:45.
1 second.
And we also need you to change out AV2.
Hold on a sec. Let me get my note. Okay, Bill, copy. Change AV2 and set up TV-21 to do a possible run of experiment 326 to 345.
That's right, Byron. That's a solid copy. And if you do get the TV set up, we have a chance for some live video at 3:35.
335?
3 plus 35.
Okay, but that's before you want me to start the experiment, right?
That's affirmative.
Okay, well, I'll get to it.
Okay, and we got a little pass coming up at about 2 plus 55 for about a minute, and we can talk to you there if you got any questions, or we'll just let you go.
Okay, then we'll go ahead and get it set up and either do experiment 25 early or delay it until after the TV and the OCM.
Okay, we copy. Thank you, Byron.
Bill, did you hear that comment the orbiter cassette? No problem.
Okay, we copy. No problem on that change out. And Space Lab Marshall Ops, we have you for 49 minutes through Teeters.
Hey, Bill, we got one item here I need to talk with Houston about, so let me... Over.
This is Houston. Go ahead, Space Lab.
Hey, have you got the ASCS procedure that you teleprinted up to us some time ago nearby?
Stand by. We'll get it. Okay, Owen, we're looking at it.
Okay, we're down through line 43, which means that we're flowing O2 into the Space Lab and atmosphere at the moment. And in just about 2 minutes, I'll do steps lines 44 and 45. However, we don't think we want to proceed with line 46 just yet because the vacuum gas system on the MSDR is still up and running, and to do line 46 requires us to close off that vacuum line to the vacuum gas system. So I think what you ought to do would be to check with the payload people to see what the implications of that will be, and let us stop at line 45 and sort of regroup and decide how long you want us to wait right there. Over.
Stand by, Owen. Let us check it for a minute. We'll get right back with you.
Okay, that's fine. We'll go ahead up through line 45 here, but then stop.
Okay, we concur with stopping at 45 until we contact you.
Okay.
Space Lab Houston, air to ground 1.
Okay, Houston Space Lab, go ahead.
Roger. As best we see it down here, we don't see any material science operations for the furnace going on at this time. Is that your understanding as well? Over.
Well, we understand they need the vacuum gas system. Let me check with Marshall Ops unless you've done that already.
We've gone ahead and checked with them, and they don't see any reason for us to need that experiment vent line vacuum.
Okay, so they see no problem with going ahead and closing off that vent line to the vacuum gas system.
That's affirmative. You can go ahead and close the experiment vent line shutoff valve. That's on R6 Alpha, and proceed with line 46. Over.
All right, fine. Thank you very much.
Columbia, Houston, over Bermuda for 4.5. You likewise, Brewster. I've got a change to your entry weather data, message number 151 when you're ready. Okay, for orbit 148, KSC is now go. The winds are 360 at 10, but there is an additional scattered cloud layer at 3,000. Over. Did you not copy that last, Brewster? Columbia, Houston.
Hello, this is Space Lab.
Oh, how are you doing?
Marshall Ops, this is Space Lab.
We copy you off. Go ahead.
Okay, I have an urgent question to the 300 systems people. Space Lab Systems is using the vacuum line here, and I'd like to figure out what the status of the vacuum gas system of the MSDR is.
Okay, we understand your question, and just a second, we're talking with the 300 people.
Okay.
And off, we don't need the vacuum gas. Everything on that, all of our data indicates that that system is no longer needed.
Yeah, but is it still running, or is it the power switches are all on, but the ops light is off?
It's
and
not.
none of us switched it ever off.
Space Lab Ulf, this is 300 Ops. Do you copy?
Yeah. Hey, Mel.
Yeah.
Space Lab Systems is bleeding air in the vacuum gas line for a system checkout. And my understanding is that the vacuum gas system is still running.
No, Wolf.
In spite of Mel.
Wolf, this is 300 ops. We set down the vacuum gas system yesterday after we sustained the water pump failure. And the only thing we're running now is the fluid physics module.
Okay, who did that then?
It was done on Byron's shift yesterday.
Byron did it, okay, because the power switches are still left on here. And I switched them both off.
Okay, he should have followed the normal procedure to set it down.
Okay, is it set down or is it not set down? That is the question here.
We show it set down, Wolf.
I think it is set down.
Wolf, this is 300 ops.
Go ahead, Mel.
We instructed him to go through the set-down procedure.
You come in broken.
Only through steps 1.5, not to set down. We don't want to do a power set-down, just the vacuum gas system. So he was told to do on procedure F900-1, just steps 1.1 through 1.5.
Did that.
That's all. And then we leave the rest alone because we still want to run fluid physics module.
Okay.
Mel, you are breaking up. Would you say again what time or what were the conditions under which that was done?
Roger. It was yesterday after we had the ICS pump failure. We instructed Byron to do a set-down of the vacuum gas system using procedure F900-1, steps 1.1 through 1.5. Did you copy?
Okay, he said F900-F1, steps 1 through 5. We'll check.
But we did not want to do a power set-down, just the vacuum gas system.
I understand.
And Ulf, this is 300 ops. One last comment. Can you copy?
Go ahead, Mel. We're ready to copy.
Okay. Our data indicates it's in the proper condition.
Okay, we understand.
Okay. Hey, well, let me ask you one question, just to get away from the confusion here. Do you agree that we switch the pump on and the vacuum gas switches to off? The two switches for the vacuum gas system, because that is confusing information.
Yes, that's okay. You can do that. Ulf, this is 300 ops.
No, Wolf's not on the headset anymore. Byron's back on.
Okay, Byron, I'd like to ask you one thing. Later today, you have to prepare the FPM for landing. Are you familiar with how Ulf removed that Y direction screw?
He wouldn't tell me. He said I'd be ashamed if I heard how he did it.
Well, you're going to have to replace it. I thought maybe you ought to find out how he did it.
I'll ask him. Thanks, Mel.
Okay.
Okay.
And Space Lab Marshal Ops, Byron, if you have a chance to copy, the 300 PI has information to pass up to you. And Space Lab Marshal Ops for Byron, the 300 PI would like an opportunity to speak with you.
Okay, Bill, we reach loud and clear, and go ahead and enable them, and I'm standing by.
Okay, Luigi standing by.
Special Lab, this is 326 and 328.
Roger, go ahead, 326 and 328. Go ahead, Luigi.
Hi, Byron, how are you? Now, let me, before we go, Lois, let me summarize what you are supposed to do. You are supposed to please run Madame Rodeau, experiment 326, which consists of the setup and step number 4. For this, you use Madame Rodeau films. If you run into difficulty and then, you know, after half an hour or 45 minutes, you just stop it. Are you copying me?
Roger, we read you loud and clear,
Okay.
Let's see. There's no film left, so you just want this on videotape, is that correct?
No, but no, if Madame Rodeau has no film, then forget about her. How much of videotape? Because you only have 55 minutes of videotape, and this would serve for my experiment. Do you copy me?
Oh, I'm not sure. Could you please try again? I don't think I understand what you both want me to do. Over.
First, let me ask you a question. Do you have? Does Madame Rodeau has film left?
Let me see.
Let's say change 326.
Hey, there is one magazine, 326 Bravo, and I don't know how much film is left in here, though, Luigi.
Byron, put it on TV.
Okay, and you want me to run about 45 minutes of her experiment?
No, I'm sorry. I mean, it's up to them to decide, but if you only have 55 minutes, then I will be, my Marangoni that will be out.
Okay, well, I've got Madame Rodeau set up first. I can go ahead and run some of hers. And Ulf advised me that we can only make the smaller drop, not a large 40-millimeter one. So I'll try and take it on film and videotape and see what we get. Over.
Special Amp, this is 328 now.
Ed.
Okay, you can use all the video you want, they told me, because you have plenty, paintball tapes. Now, let me try to explain what I would like you to do for my experiment. Now, you use 5 centi-stokes and try to get the tallest possible column. And if you don't get it, whatever column you have, start making oscillations with the rear plate and take recording. And then I will have AOS again. Did you copy me?
Okay, we copy. Long column, as long a column as we can make, and oscillations with the rear plate.
Yeah, but before you get the Marangoni flow with heat up, of course. I forgot to mention that. Copy?
Can we copy? Well, we'll try our best.
Yes, of course, I know that you
Problem is,
your best is
doesn't
good.
the heating happen from the front plate, over?
That's right. It
Okay,
happens.
but the front plate has that plastic disc on it.
No, you have to put my front plate, the 60 millimeters, my front plate, 60 millimeter.
There, Marshal.
And Space Lab, this is Marshall Ops. We've got you for about 6 or 7 minutes here through Hawaii.
Okay, we all got you loud and clear.
And Luigi is standing by, Byron, if you need to talk to him.
Okay, well, it is strange has happened with the reservoir here, the 5 centistoke without tracers. And for both reservoirs, I was unable to get any fluid out with a manual injection tube. And I then tried to roll in the reservoir a little bit using the normal speed. And I don't know, I think the 5 centistoke without tracer reservoir was about empty, so I'm about to switch over to the 5 centistokes with tracer, so it'll be a little bit of time here before I'm ready for any help or information.
Space Lab 328. Okay, Byron, it's all right. I mean, you should now please go to my experiment, which does use the 5 centistokes with tracers. And as I tried to tell you before, the main objective is to get as tall a column as possible, as high as possible, and heat it up and record extensively the Marangoni flow. However, whatever column you get, you record it and then start with applying oscillation at the real plate. The point is that you shouldn't waste too much time in trying to get a tall column. Short of this, I would very much like to investigate what new phenomena will occur when you have Marangoni flow and oscillation of the real plate. And you could span the frequencies starting from 0.1 and going up by steps of 0.2. Did you copy me?
Roger, I copy. I wish you told me yesterday we had that lovely long column. We could have heated it, and we did some oscillation yesterday. I think I'm duplicating my work up here, Luigi.
Yeah, I'm sorry to tell you that, but you see, I was given that much time, and while I asked yesterday, I was given it only today. I really sorry for that.
Let me look at the schedule here. Hold on a sec. Marshall Ops, Space Lab here for the CIC.
Go ahead, Byron.
So, what's the schedule look like today? It's really just cabin stow, right? No 25?
That's affirmative, and we've got you on our schedule doing the MSDR fluid physics module activities to around 6.
Okay, I never saw that here, which is fine. It's no problem. What I want to do, I've got Sam Rodot's plate set up. Why don't I go ahead and see if I can get a fluid column in here? I didn't have any luck with the other fluid. And see if I can get a ball and put a little bit on TV here before we switch end plates.
Okay, Byron, for me, go ahead. Don't worry, go ahead.
I think we'll have enough time.
And Space Lab, we'll see you in about 14 minutes through S-band.
Space Lab, this is Marshall Ops. We have you with Tidris for about 48 minutes.
Roger, Marshall Ops. Got you loud and clear.
Space Lab, this is 328.
Roger, go ahead, Luigi.
No, I just want to know the status. Where are you?
Okay, well, I thought I would go ahead and grow a bubble and film a little bit for Madame Bordeaux since I have all the equipment set up. And finally found out what was the matter. I made a mistake in installing the plates here.
Yeah. Space Lab 328.
Go ahead.
How much more time do you need for Madame Bordeaux?
It'll be 15 or 20 minutes.
But then this will kill my experiment.
And Space Lab, Marshall Ops for Byron.
Go ahead, Bill.
Yeah, the way our schedule shows here for through hour 6, or correction, 2 hour 6, we'd like to have you get started around 5 if you can on Luigi's experiment, if that'll give you ample time to get some data for Madame Bordeaux.
Okay. So I'll do one sphere here and do some different oscillations. I'm just about ready to grow it, and I'll get the video set up here shortly.
Oh, that's super, Byron.
I had a little trouble up here.
Okay, we understand. Thank you very much.
You guys going to get any real-time TV?
No, we're not going to be able to get any real time on this pass.
I understand. We've got the whole tape here to use to cover this. Is that right?
That's affirmative, Byron.
Okay. Okay, we're starting the tape recorder now. We're starting to grow the 30-millimeter drop.
Okay, we copy.
And it's plainly visible here on the video monitor.
Okay, fine, Byron. Thank you very much.
Okay, and we got a 30-millimeter sphere, and we're going to begin to oscillate here. I'll just be calling out on the loop here for documentation on the tape recorder.
Okay, and that's a good idea.
Here comes 0.1 hertz. It looks like it's pretty much solid body rotation. Here comes 0.2 hertz mark. Strange, you'll have to check the camera and the bubble disappeared. We're at 0.2 hertz. 0.3 hertz mark. 0.4 hertz mark. Still appears to be a solid body oscillation. 0.5 hertz mark. 0.6 hertz mark. 0.7 mark. Seriously, the bubble keeps disappearing slowly. It must have some air in it, so I'm going to go ahead and create another one here.
And Space Lab, this is Marshall Ops. Byron?
You go, Bill.
Yeah, I guess Luigi has some druthers, and I guess we'd like to ask for what your feelings are. Are you too tired to continue?
I'll be fine. What's the big press to get done by 6 o'clock?
You need to start on your cabin stow activities. I'm not so sure that it's totally clear everything that you need to be involved in there, but I'm sure we could let you run over maybe a few minutes or so. But let us check it.
Yeah, I mean, I don't see anything, we're doing cabin stow all day today, and these guys are doing cabin stow all day tonight. We're supposed to be setting down the MSC here at about 10 o'clock, so I've got no problem going for another couple hours here, but, you know, this is the type of stuff you just can't do and program it down to the minute. Work.
Okay, we'll check that out. I don't think we'll have any problems. Let me check here with Bo Chanel.
I'll be happy to do Luigi's work. I mean, I'll be happy to terminate right now, whatever you want, but, you know, if you want to get some science, it's going to take a while to get the experiment set up to do it.
Okay, and we'll work that. We'll be right back with you in a few seconds.
My druthers are to go ahead and press on for another couple hours and do a good job on both of these, and then we'll go ahead and do the cabin stow and shut it down.
Yeah, I think that's the way we're leaning. Just stand by.
Spin 0.7 hertz. 0.8 mark. 9 hertz. And I'm growing the bubble here manually now. It just keeps the air in the chamber.
And Space Lab for Byron, you have a go till 7 o'clock, Byron.
Okay, sounds good, Bill. Thanks. 0.1 hertz mark.
And Space Lab Marshall Ops for Owen.
Bill, Owen's in the mid-deck. Go ahead.
Okay, you can just, don't bring him back down. At between 6 and 7, there's another opportunity to help the 01 PI Marcia Tour out to obtain some additional photographic data. So if he could float up there to the aft flight deck and look out the -Z axis and take some more photographs, she certainly would appreciate it.
Okay, we copy. Thank you. Marshall Ops, Space Lab, over.
Go ahead, Owen.
Byron just tells me it's 6 to 7 o'clock MET for the next set of ISO photos, and I just thought I'd tell him that the last set taken, let me see, whenever that last hours
yeah, we have the hours
were requested. Okay, but I wanted to mention it's row 122.
Okay,
row 122.
Yeah, copy 122, Owen. Thank you very much.
No, that last VTR tape on number 2 was number 23.
Copy 23 on that tape. Appreciate that.
And we're beginning the oscillation now again at slow ramp up to 1.1 hertz.
And Space Lab Marshall Ops for Byron. We're going to have live TV from the module at about 5 plus 20. That's a little less than 6 minutes from now of the... we're going to be using camera number 2, and we'll be able to look inside the fluid physics module.
Okay, Bill, sounds good. 1.0 hertz. Now, Bill, once you get a little bit of this on the drop, then I'll go ahead and I've been getting some stuff here on the videotape. Then I'll go ahead and shut it down and go to Luigi's.
Oh, that's great, Byron.
0.9 hertz. 8 hertz. Oh, it just spilled over again at 0.8 hertz. Bill, how you guys coming on your live TV?
Not yet, Byron.
Now the hose just popped off. We'll stop here and go on to Luigi's.
And Capcom wants to use a loop.
Columbia, Houston, on air to ground 1.
Houston, Columbia, go ahead.
Roger, Brewster, We'd like you to turn FES A off, OFF, now. We'll try to make some water, and we'll let you know how that's coming and whether or not we still need to go to a cold
Columbia,
attitude
go
later.
ahead.
Columbia, Houston, on air to ground 1. How do you read?
Houston, Columbia, how do you read?
Loud and clear. How me? Columbia, Houston, on air to ground 1.
Houston, this is Columbia, go ahead.
Roger, Brewster, we'd like to make some water, and to do that, we'd like you to turn FES A off. We'll keep an eye on that, see how the water's doing, and we may have attitude change for you later.
Okay, you want to turn FES A off, and you're going to watch the temperatures for me.
Roger, we'll watch until we go LOS, but we think they'll be okay. We don't see any problem with the temps.
Okay, well, one rad out is at 57, the other's at 37. What do you want me to do if it doesn't stabilize at a reasonable level, and what do you consider to be a reasonable level?
Columbia, Houston, Brewster.
Go ahead, Brian.
Brewster, once we go LOS, go ahead and turn FES A back on. If either of the two happens, 1, you get the alarm. 2, if the average between left and right gets above 55.
Okay, I got you, and I'll turn it off.
Roger that, and you may pass to the guys in back that we're getting live TV from them right now.
Okay, fine. Sure, Brian.
And Brewster, we're going LOS now. The next TDRS pass starts at 6+08, and we'll see you at 5+34 at Yargadee.
Okay. Now growing a cylinder here for Luigi.
And this is Marshall Ops. You copy, Byron?
Bill, we got you loud and clear now.
Okay, we copy.
Okay. Is having live TV this fast?
Byron, we will have live TV at the end of this pass, and I think that will be at about 6:50. We'll have live TV. We can't get it before then because of the K-band. And Space Lab Marshall Ops, we've got you for 48 minutes. And Space Lab Marshall Ops, we have you for 48 minutes through TDRS. I'll copy. Space Lab Marshall Ops through TDRS for 48 minutes. I'll copy.
Loud and clear, Marshall Ops. How do you read me? Over.
Loud and clear, Byron. And we have Luigi standing by when you're ready.
Okay, very good. We've got an 88 millimeter column now, and you can advise the MSTR systems folks that the oscillation motor is not working today. It doesn't come on, and we're not getting any rear plate oscillation. Over.
Okay, we copy. We understand. Thank you.
Right, it was working yesterday, okay?
Space Lab 328.
Roger, go ahead, Luigi.
Byron, it's wonderful. Did you get a chance to film the Marangoni flow in this 88 column?
Not yet, because I had grown it with iso rotation, and I've just stopped the plates, and I'm waiting for the tracer motion to stop. Over.
I understand, but it would be very, very nice if we could get some Marangoni flows of this column that high. That would be a record, you know, in the world.
Roger, understand. We'll be ready to go in a couple of minutes. Will you all have television coverage this fast?
Great, you're great. If that goes, it's great. But we don't have it yet, they tell me.
Byron, we'll have
well, the television...
Excuse me, Byron, go ahead.
Bill. Go ahead.
Okay, we'll have it at 6 plus 52. That's about 40 minutes from now.
I'll try and describe to you then, for both your benefit and the tape recorder's benefit as best I can what's happening, what I'm doing. Right now we're just waiting. That column takes several minutes for the tracer motion to damp out once you stop the rotation. Okay, we've got the recorder going again, and the motion looks steady, so we're going to go ahead and turn on the heater now.
Okay, wonderful.
Okay, I've got the heater on.
Great.
Marshall Ops, Space Lab, how hot does the heater get? Over.
And Byron, that goes up to about 60 degrees centigrade.
Okay. We have that plastic disc stuck on there. I think it'll take a few minutes for the heat to transfer up through the Perspex plastic.
Okay, we copy.
Okay, no tracer motion yet. LOS, and now got a 19A crew alert, 41.
Yeah, we're copying those, Byron. We're seeing them come on the message line now. And disregard.
Good. And there's still no tracer motion. Turn the TV camera off here until we start getting some.
Space Lab 328.
Roger, go ahead, 328.
Byron, if you cannot, heat it up, because if I understood, in top of on top of the heater plate, you have a perspec or whatever you call it, the mic's disc.
Roger, that's affirmative. There is a plastic disc that is sticky back taped onto the metal front plate.
Yeah, but then it's very difficult to get the heat through that, don't you think so?
I do.
Okay, so why don't we, you said you cannot oscillate the rear plate?
Affirmative, Luigi. Something happened to the oscillation motor and it is not running.
I understand. Neither one, or was only the rear plate?
Sorry, say again, please.
Space Lab for Byron, this is 300 ops. Can you tell us what end plates you have installed?
Hey, it's the front end plate is the 40 millimeter disc, Mel.
Thank you.
On top of that 40 millimeter disc, we've sticky back taped one of Mike Haynes' plastic discs on it to enable us to form the column. But I don't think we're getting enough heat transfer through there to be able to excite the liquid.
Roger, we copy that.
Okay.
Space Lab for Byron, this is 300 ops. From our data, we're not seeing any heat at all come into that end plate.
You're not seeing any heat to the end plate, huh?
No, we're not seeing anything. You sure the connectors are mated?
Yeah. Okay, well, I could certainly explain why we don't have any tracer motion.
Say again? Oh, yeah, because no heat. That's right.
And Byron, just disregard the 19A error messages. We'll try to get those stopped here in a second.
No. Okay, Luigi, well, we're standing by here. What would you like to do next?
I leave it up to you, Byron. What I am interested in is to get heat and temperature. So I don't know what to say, because I'm afraid that I'm a little bit lost. I don't know what your possibilities are, what you have, what you don't have, because that has been used by others. So it's up to you. If you could just give me not give me not a very tall column, but heating. This would be good for me.
Roger. Well, I don't know what to say here.
But did you use the Fiat plate?
Got John Paday's rear plate in.
This is the thing. Is John Paday's rear plate in? But
Okay, well, if we're not getting heating,
Yes.
so why we don't have any,
Space Lab, Byron, how long do you think it would take you to install the other end plate? Luigi is really interested primarily in getting some heating.
okay, you mean the rear end plate?
The normal Fiat end plate on the front.
That's what I have in on the front, Mel. But I've got a plastic disc that's stuck to it.
Okay, stand by.
You should take that thing.
What you can do is recover the column and pull it out and check make sure everything is seated properly in there.
Okay, Byron, you know better than I, and go ahead.
Okay, well, if that's what you're interested in, I guess we ought to try that, because if we're not getting the heating, that doesn't help you. Let me try the oscillation motor again.
Yeah, that's right. I mean, if I don't get any heat, I'm not interested in that.
Okay, we'll go ahead and start recovering.
And Byron, you can also ignore the timeline 04 message.
Okay. Admit I didn't see that one, Bill. With 23 of them queued up there.
Roger that.
Space Lab, Byron, 300 ops here.
Roger, go ahead, 300 ops.
Yeah, we've been talking with Luigi here, and I think what he would like to do in the remaining time is just try and recover what he can here, is have you go back to using the normal end plates according to his procedure, and not with that little plastic disc on, and try one more time.
Okay, we copy.
Thank you.
Go up, Space Lab.
Go ahead, Byron.
Would you mind reminding us again of where that locker in the middeck was that had those extra tissues that you mentioned a couple of days ago? Stand by, looks like. Yes, my question remains. Please, if you got that, I'd appreciate it.
Yeah, we've got it here. Let us check in our log.
Bill, don't worry too much about it. Looks like Brewster's already got it here.
Okay, Owen, we copy that you already found them. And Space Lab Marshal Ops for Owen.
Ben?
Owen, we've got some alphabet soup here for you to copy relative to a crew stowage checklist, if you got a chance. You'll need some pencil and paper.
Hey, pages. Any copy, Bill? Go ahead.
Capcom has got to come up first, Owen.
Columbia, Houston, on air to ground 1.
You just begin. Go ahead.
Roger, we've got a orbiter and TDRS state vector delta coming up.
Okay, thank you.
And Owen, are you ready to copy?
Ready?
Okay, during your stowage times, we'd like to have you inspect all these decals on the front of the doors and the closette panels, and we need to, these are secure for re-entry. If you have any problems, we want to have you let us know. I don't think you will, but if you're ready to copy, we'll give you the drawers we want you to check on the module starboard side first.
Go ahead.
Stand by, Owen.
Okay, Owen, what we would like for you to do is to check all the decals on the module starboard side, on the port side, the overhead, and the orbiter. If you need any...
Doesn't leave very much else.
Yeah, I understand. And if you need to know the drawers that we are interested in, we'll read them up to you. It's a long list. You probably don't need them, But we have two other...
It had been our intent to make sure that all the drawers and doors were closed and ready for entry. If there's anything beyond that or special, why, you could let me know, but we'd plan to make sure everything was ready.
Okay, we just got two additions that we want you to do. We want you to verify there are 20 pots and plants in the Peacock, and verify that there are 4 pots and plant modules in Romeo 8 Victor.
Okay, I have that.
Okay, roger. And I thank you, Owen. We know you're going to take care of all that.
Okay, fine. That wasn't such a bad job, but I'm sure you had it abbreviated.
Marshall Ops, Space Lab here for the MSDR systems, folks. Marshall Operations, Space Lab here for the MSDR systems, people. Marshall Ops, how do you read Space Lab, over?
Byron, reread, how are you?
Hey, loud and clear. Get hold of the MSDR systems people and check out and see. I'd like to check this heater operation before I go ahead and make the next zone, over.
Okay, we understand.
Hey, here we go.
Space Lab for Byron, this is 300 ops.
Go ahead.
We're having a little difficulty with our data right now, so we can't track you through that heater operation. Hopefully we'll get it in a moment here.
Okay. Hey, I'm going to look at my temperature readouts here also, Mel.
Good, okay.
Hey, we confirm, got good heater operation now. I reset the plates.
Very good. Very excellent, Byron. A wonderful job you're doing.
Be better today. But I haven't taken off the plastic disc yet. Do you want me to go ahead and try the column again? It won't take me but about 2 minutes to grow it.
Okay, go ahead. Go ahead. You're doing a wonderful job, Byron. Excellent. Thanks.
Okay, here we go.
Space Lab 328. Byron, don't worry. Don't worry to make it too long. You know, if you cannot make it too long, never mind.
And Space Lab Marshall Ops for Owen.
He's up in the flight deck right now, Bill.
Okay, Byron, when he has a chance, have him give us a call. We've got you for about 7 more minutes.
Okay. Marshall, Space Lab, go ahead.
Yes, Owen, are you coming okay with your stowage, or do you need Byron's help at this time?
No, I'm getting along all right. As a matter of fact, things are not too tight.
Okay, we understand, and thank you very much for that input. And be advised, Byron, we're have live TV of the FPM.
Hey, very good. Few bubbles here. Usually I haven't seen that many bubbles. Long time. We'll stop with this column, which is 66 millimeters long here. Luigi, and we'll go ahead and turn the heater on.
Space Lab 328.
Record on the ground. I guess I don't need to record here.
That's
Go ahead, Luigi.
Okay, I want to talk with you before I get LOS. I want to thank you very much. You did a wonderful job. And I look forward to seeing you at the next meeting with Elgra, and happy landing. Thanks again, and I really don't know how to express my appreciation for you taking overtime work and overtime load. Did you copy me?
That's no problem, Luigi.
Okay, happy landing.
Roger, we read you loud and clear.
Happy landing.
Yes. Get rid of some of these bubbles. I don't know where these came from. Last time I just had the two small ones in the bottom.
You are on live coverage. We see you now.
Okay.
It's very good. And before I forget, you just record everything, of course.
Wilco.
Anything you give it to me is plentiful of invaluable scientific information. Keep this in mind, and you already provided me with an awful lot. But keep going.
Okay. Okay, I see tracer movement now.
Could you say that again, Byron?
Roger, I see tracer movement.
It's what we see. I see wonderful thing from now here. Keep going and keep recording, please.
Wilco.
And you know what? You can also do something like that. Just hit the thing like simulating a G-jitter. This would be great. Did you copy me?
No, say again, please.
As I said, you can just also hit the thing simulating a G-jitter, and and give me some record on the voice that you are doing that.
Okay, I understand, Roger. Luigi, looks like we have tracer flow now from the outside edges along the front end plate and then up the middle.
Yeah.
It looks like it's developing more and more.
We saw them here too. It's great. It's just great. It's extraordinary. Just great. A wonderful job.
Try and focus a little better here.
And Byron, be advised you may get some. Be advised you may get some 21 error messages. Just disregard them.
Hey, you guys still have live downlink?
That's affirmative.
Hey, you got TV2 piped in there?
That's affirmative on that one too.
Hey, you should be able to see the tracers now on the TV screen. I was able to focus a little better.
Yeah, I can see perfectly well now. And as I told you before, try to give him a jitter now, G-jitter.
And Byron, you can continue what you're doing here. You need to wind it down and have everything wrapped up in time for your activities with 21 at 8 o'clock, and help Owen as needed.
Understand, Bill. Wilco.
And
okay.
Byron, we can turn recorder 2 on if you like, or you can do it.
I'm set up here to do it, Bill. I'll get it. Thanks anyway.
Okay, you're fantastic. It's just fantastic. Let me say thank you again. Happy landing, and keep jittering the stuff, huh? And recording it.
Okay, welcome.
Happy landing.
Okay, Luigi, we'll talk to you soon.
And Byron, we'll see at 7+40 through S-band.
Bill. I have notified the park.
Bob, we sure thank you very much.
And next time you have them write all three procedures as a chain instead of on three separate procedures. We're going to do all three of them.
We copy, Bob. Thank you very much.
Space Lab Martial Ops, we have you through TDRS for about 51 minutes.
Hey, Roger, Martial Ops 3 loud and clear.
And Byron, if camera 1 is set up, we can see you on live TV.
Hey, stand by here. Move it around.
And Byron, we've got you on live TV. And Byron, if you could go up to the window, that's the aft window on the bulkhead, and check to make sure that all of the ISO doors are closed, we would appreciate it.
Here we go.
That's a real good picture, Byron.
Help the kick.
That's a great flutter kick.
Okay, let's see, where's ISO? Oh, it's down there, isn't it? All the doors are closed on ISO, guys and girls.
Okay, we copy that, and thank you very much. And when you run 21, that's coming up, we have Dr. Krumalik, and he will be enabled at about 8 o'clock.
Okay, sounds good.
And this is the last TV session that we will have of you all until deactivation.
Oh, no kidding, that's too bad.
Byron, you're having too much of a good time, it looks like.
Absolutely right, Debbie, this is great. And Bill, if you've got the MSDR people around, I was looking for a piece of equipment called 300.25.
300.
Like a very little fit.
Okay, we're looking for it, Byron.
Okay. One slot left in here that's unfilled in the drawer.
And Byron, we're going back to S-band, so I guess that's all the TV we're going to see. And Space Lab Marshal Ops, how copy, Byron?
Hey, Bill, we've got you loud and clear again.
Okay, those disc removal plugs for the FPM, the ground thinks they may be on the inside front plate of the FPM. There's some bungees there. You might check there and see if you can find it.
I know, I've got it. I looked it up in the meantime, thanks. It's all set.
Okay, great.
Still getting live TV, or is it,
No, Byron, we lost our K-band, and we won't have it anymore this pass.
I'll go ahead and turn off the TV camera.
Okay, thank you. Copy that. And Byron, if you're close by the aft window on the end cone, we'd like you to look out and see if the 19 door is also closed.
Okay, Bill. Roger, cover's closed on 19, Bill.
Okay, we copy in the PI for 19. Certainly, thanks you.
Marshal Ops, Space Lab.
Yes, Byron?
Roger, Bill. On the 21 confirmed solar pointing, it is confirmed.
Okay, we copy, and we do have the 21 PI, Dr. Krumalik enabled.
Space Lab.
Okay.
This is the PI-21. I congratulate all of you for your tremendous performance, especially for your support to our solar observations. I hope you did not get too warm. Have the good wind for landing, and we expect you in Brussels in January. Over.
Very good. Thank you very much, Dominic. It's a pleasure. And tell me, what is your preliminary number for the solar constant?
That's the surprise for Brussels meeting.
Oh, okay. Very good. I hope your instrument worked okay. I know there was some problem with the ECAS early in the mission, but we hope that the instrument itself worked fine.
Indeed. It's very good. Right.
Thank you. We'll look forward to seeing you later.
And Space Lab for Byron.
Hey, Bill.
Yeah, we have a Sierra Oscar Papa Foxtrot message in XTLM for you.
Roger, Bill. We copy your message here.
That's great, Byron. And Byron,
Our message?
yes, we do, and we'll take care of that, they say, when they get back to the PCTC.
Okay.
And Space Lab for Byron.
Go ahead, Bill.
Yeah, we've got some activities that we need you to start at about 8:55, and no big rush on it. We'd like to have you do a TV 2.5 setup. That's for the Space Lab deactivation.
Okay.
Okay, appreciate it. Yeah. And Space Lab Marshal Ops, we've got a short deact procedure on AEPI for you to copy if you got some paper and pencil handy.
Good, Bill. Ready to copy.
Okay, on the Romeo 5 mic panel, we've got 3 steps for you. Thermal power on. Module power switch to on. And pallet power switch to on. Then on the Romeo 5 Lima panel, I want you to check that the pallet system select switch is in primary. Check that the power primary light is on. The shutter calibrate shutter switch is closed. How copy?
Solid. Just a moment. It'll only take a minute to do that.
Okay, and we've got a little bit more for you.
Okay, all those steps are closed, Bill.
Okay.
All those steps are complete. All those steps are complete.
Yes, we understand. Then we want you to do a pallet system select switch to off. This is again on the Romeo 5 Lima panel. And then check that the primary light is off. And we want the primary and secondary circuit breakers out.
Complete.
Okay. Then back to the Romeo 5 mic panel. We want the pallet power switch off. The module power switch off. The thermal power switch off. The system and the depth feed circuit breakers out.
All complete.
And then to the Romeo 5 Nancy panel, we want the power bus feed circuit breaker out.
Complete.
That's great, Owen. That deacts AEPI.
Good.
And we may have a RADI S-band on the next pass at about 9 plus 17. We do have a 16 procedure that we will be reading up to you at that time.
Okay, I noticed one on the cap that I thought I could find in a procedures book here. You want me to do something else that, yeah, it looks like it's F900 in the book.
It's different from that, Owen. It's kind of a complicated procedure that Well, we'll get it up to you.
Okay, you'd rather do that than on a teleprinter, huh?
Yes,
Whatever you say.
Yeah, we would rather do all this by teleprinter, Owen, but I think we're out of paper.
I think you're right.
And we'll see you at 9 plus 16.
Okay.
And Space Lab Marshal Ops, how copy?
Clear, Bill.
Oh, great. Have a message for Owen on 16 if he's ready to copy.
Copy, Bill.
Okay, Owen, this is 13 steps and a little bit complicated. We can do it this way or go up by XTLM. Which do you prefer? And Space Lab Marshal Ops, how copy?
Okay, we're back together, Bill, and if it's just as convenient, XTLM would be a little better.
Okay, we'll do it that way. Okay, stand by. You can call it up in a few minutes, Owen. We're having drop-ins and drop-outs, as you can tell.
Okay, that'll be fine.
And Owen, I think it's on board now. And we've got some instructions after you can copy that down.
Okay, fine. What STL?
M, Mike, Alpha, Bravo, 00.
Mike, Alpha, Bravo, double lot.
That's affirmative.
Somebody down there types faster than I do. Like a lot of people. Okay, Bill, I understand those 13. Any other discussion?
Okay. And we've got one other message for you, Owen. We want to advise you that ECOS control for the experiments is going to be terminated on day 9, 10 plus 55. And naturally, all the payload mal recovery procedures for the experiments will be no longer applicable.
Okay, I understand. I presume that's the ground scheduled ECOS crash occasion.
That's just prior to, Owen.
Okay, and when would you like for me to do this 16 procedure?
At standby. And Owen, that is at 10 plus 35.
Okay, I wanted to make sure that's what your last line 15 meant there. Okay, 1035. We'll do that.
Okay, and I have a message to pass up from our pod, and I'll read it to you. It says, Owen and Byron, I would like to take this opportunity on behalf of the POC Cadre Blue Team and the experimenters to say thanks for your hard work and dedication on making this mission so successful. It has been a pleasure and an honor to work with you and to be part of the Space Lab 1 payload operations team. We wish you a safe deorbit and landing and look forward to seeing you at the debriefing.
Thank you, Bill. And Clark, we really appreciate those generous comments. We'll talk more about it on the ground, but we really do appreciate your saying so here out on the loop. Unfortunately, Byron isn't on the loop right now, but I will relay those sentiments to him. We really appreciate it.
We copy. And Space Lab, this is Marshall Ops for either Byron or Owen.
Can you read me still, Bill?
Just barely, Owen. I'll do the talking.
Okay, I'm up on the flight deck, but go ahead.
Okay, this is actually for Byron doing his work on the cryostat, but I think you probably know that we need you to check the tightness of all 8 screws that's on each sample container after removal from the cryostat. And we need you to tighten those screws with Allen key M3, and it's located in Lima 2, Echo /2.
Okay, with the Allen head, Mike 3, Lima 2/2.
That's Lima 2, Echo /2.
Okay, we got it.
Thank you, Owen. And Space Lab, be advised that we have you on TV from the bulkhead cameras out in the payload bay.
Okay, we're just going in darkness there, Bill.
Okay, I was hoping we'd see you outside, Byron.
Not that good at holding my breath.
Great.
I'm hoping you don't see us outside.
And Space Lab Marshall Ops to Owen.
Hey, Bill.
Yeah, I think you better go past entry 7. You need probably to go to entry 13 on that MM Alpha Bravo 00 timeline.
We're going to do all of those steps. What was this question about?
Okay, there's some additional instructions at the end of that. You need to make sure you can read through step 19.
19? I thought you said there were only 13 steps.
Okay, 13 steps, but there's some instructions with it.
Yeah, I'll take a look.
Total of 19 lines. And Space Lab, we have this unique opportunity to visit you once again inside the module if you have a camera set up.
We have the aft bulkhead camera, number 1.
Okay, great, Owen. We'll come inside and look at you one more time.
Oh, let me take it. Just a second. I haven't got the plug in it yet, so I'll have to go put the plug in it.
And, hi, guys. We see you once again.
And, Marshall Ops, Space Lab for the MSTR 300 people.
Okay, hold on. We'll get them on the line.
Ma'am?
Space Lab Byron, this is 300 Ops.
Roger, 300 Ops. You're a little weak, but I had a question about the 3 launch lock pins on the fluid physics module. We've got it all the way pushed back in, and I'm having a tough time getting them lined up. Does that module get all the way back in, or does it come out a little bit?
Stand by. I think it goes all the way in, Byron, but just a moment. Space Lab 300 ops here. Gonna put Jürgen Schuran on. He's standing right here, so he's gonna talk to you now.
Okay, thanks, Mel.
Byron, the 300 ops.
Grüß dich.
Ja,
Grüß dich, Jürgen.
Ja, thanks. Danke, sehr gut. Byron, you have first to screw in the screw in Y direction as much as possible. After that, screw in the 2 screws in the X direction. You copy it?
Okay.
You have to have it
Okay, that's what
completely in, and then start with the Y direction.
Okay, very good. Thank you, because I was starting with the X. They're a little easier, and they won't go in yet. So,
negative. This doesn't fit. You have first to screw in the Y direction, and then start with the X direction.
Okay, we copy. Thank you very much, Jürgen. Appreciate it.
There's a lengthy set of instructions on 16 there, Bill, so better leave the timeline in place in case these round skips come along.
Yes, we concur, Owen.
Leave you guys a minute and head to the mid-deck.
Okay, Byron, we copy.
Marshall Ops Space Lab for the MSTR people. Be advised that works like a charm.
Okay, we copy that, Byron. That's great.
Yeah, Marshall Ops fluid physics module is shut down and secured.
Okay, we copy, Byron. And the 300 people have just been elated at everything you've done.
I appreciate it. We tried to do our best.
And Byron, we have a note from Harry Kraft, our mission manager, that we want to read up. Is Owen nearby?
He's down in the mid-deck stowing.
Okay, as soon as he can copy, we'll read it up.
Okay, Bill, go ahead. Go ahead, Bill.
Marshall Ops, go ahead. Owen's here now. He can hear you.
Okay, Owen, let me start now. This note is from Harry Kraft. And he says, all of us in Marshall Space Lab operations, the cadre, the management team, the experimenters, want to express our appreciation to the crew of Columbia and Space Lab 1 for the absolutely superb jobs you have done. You have made one of the most ambitious space missions ever attempted a tremendous success and proven to the world that the American Space Shuttle and the European Space Lab make an unbeatable combination for conducting science activities in space. We wish you Godspeed and look forward to seeing you back in Huntsville. You have really done a great job.
We thank you very much, Harry, and also the cadre who expressed the same wishes. We also want to thank you all on the ground because behind the six of us, there are an awful lot of folks down there that are doing an awful lot of hard work, and we know you're working at least as hard hours, as long as hours that we've been working, so we appreciate all your help, too.
Copy.
Have a loaf of fresh bread here, Bill.
We copy.
Say, we got enough food for about 4 more days up here.
We copy. And we're going to get an opportunity here on the ground to see our first sunrise in space.
Hey, we're about to shut down the cryostat.
Okay, we copy, Byron.
Marshall, Space Lab.
Yes, go ahead, Byron.
Bill, I got a question on the Experiment 31. We have, obviously, several days ago stowed the cell culture block, but the rest of his hardware is still here in the Space Lab, and it never said to return it to the mid-deck locker. Do you all want to land with it here? Do you want me to put his little, I guess, refrigerator box back into the mid-deck locker, over?
I guess we better check that one out. We'll be right back with you.
Okay.
Guys, that sunrise is fantastic.
Right. You could see a pretty good view of it, could you?
Oh, we're still seeing it. Oh, it's something else.
Sometimes the pictures come out very well, get overexposure or something. I'm glad it's so good.
And Byron, on Experiment 31, we believe you've taken the culture block back into the orbiter. It's in the freezer. We think that's already been done several days ago. The box stays in the module, and it clips there in Romeo 4 Papa.
Okay, Bill, that's just confirm what I thought. But we do have a question about the 334 experiment. You're talking about the 8, they're actually cheesehead screws here, and I don't see a cheesehead tool to make sure they're tight.
Okay, stand by. We'll get an answer on that one.
Space Lab, this 300 ops.
You go ahead, 300 ops.
Can you repeat your question, please?
Roger, about half an hour ago, Jürgen, Bill uplinked a note that we should check the 8 screws on top of the 334 containers, and he said it was an M3 Allen wrench, but all this takes is a very small cheesehead for the 8 screws, and I don't see anything in our procedures to do any checking of it. What would you like me to do on it, over?
Okay, you have to go to the drawer L2. E, echo, like echo, dash 2, take an Allen key, M3, and tighten these screws up.
Talking about the 8 screws that actually hold the plastic container together?
Yes, the upper part and the lower part, or both parts.
Well, they're not an Allen head screws. They're cheesehead, and they're very small. I don't believe we have a cheesehead wrench that'll fit them.
Okay, perhaps you can do it with a screwdriver.
Okay.
And Space Lab Marshal Ops, we've got you for 20 more seconds, and we'll just have you for one more pass at 10 plus 45. And Space Lab Marshal Ops, we have you for about 5 minutes.
Roger, Bill, we got you. Bill, we had a question about the dosimeters, the 006 dosimeters. Do they come up on the redshift to be stowed?
We show them in our PCAP here. Let us check that.
Hey, remember, we asked you about it yesterday, and you thought we ought to delay, so it did show up in yesterday's.
Yeah, pick them up today. We showed in our PCAP at about, a few minutes ago, but I'm sure leaving them down and getting them here whenever you can will be fine.
Whoever we remove them, it will probably be just about the same dose as if we left them.
Yeah, I know. That's very clever, Owen. And Owen, have you got 1-6 experiment 1-6 shut down?
Affirmative, that's complete.
Okay, thank you.
CIC 300 ops, your loop.
And Space Lab, are you shutting down the MSDR at this time?
It's already been complete, Bill. It was done at about 10:35 or so.
Okay, thank you. Appreciate it. And Space Lab, for me personally, this will be our last pass and the last time this mission that I'm going to be talking to you. And the next time you fly, I hope you take an experiment that will discover a new way to grow hair.
WD4OQD, there's you're the best yourself. I hope you can be on a flight like this one of these days, Bill, and we really enjoyed working with you a lot. Couldn't ask for better work than you've handled down there at CIC. We really appreciate that. Sure, second that.
Okay, and thank you guys very much. And tell Bob happy birthday for me, and I won't see him till after his birthday, but wish him my best, and we'll see y'all at Marshall the 20th of December.
Okay, Bill, it sounds real good, and I guess Mike and Willow have headed out to Dryden already, huh?
That's affirmative. And DMC has one message. We want both VITR tapes removed and stowed.
Now, that's going to be tough, because where are we going to stow them? We launched with 2 of those tapes in there.
Put new ones on and put those in their place.
Here we copy.
Columbia, Houston, we appear to lost UHF there. We'll see you again through TDRS at 10+57.
Yeah, thank you. Went for Columbia, sorry about that.
We'll talk to you then, too.
Okay, I didn't hear you, Anna. What did you say?
Yeah, Brewster, we'll see you through TDRS at 10+57. And we will need the panel command when you go LOS here.
Okay. And the tunnel printer's still ticking away. Are you done or not?
Brewster, we should be done.
Okay, you must be getting some spurious inputs in.
And guys, our best and happy landing, and we'll be watching you tomorrow morning coming down through the big blue sky.
Hey, sounds good, Bill, and I understand it might be your birthday today, is that correct?
Yeah, but Bob's 2 days older than I am.
9 in county. Roger that. Well, happy birthday to you, old man.
Okay, thank you, and have a ball at Dryden.
Well, I'll tell you, it'll be pure work.
Okay, I'm afraid it may be harder than the mission on you.
Columbia, Houston, on panel A15, we'd like you to cycle DC utility power to turn the teleprinter off. Then turn it back on.
So much for panel and command. What shall we try next? Okay, you broke out in the middle. 15 to 20 degrees of right roll, and say again. Okay. Want me to re-enable those and then roll right 15 to 20 degrees, is that correct? Understand we'll be go for the circ pump test in Hawaii at 12 plus 19. Okay, understand. Okay, we copy that. Okay. Okay, Anna.
Columbia, this is Houston with you through Hawaii for 4 minutes. Howdy, Brewster. Brewster, this is Houston. We saw the data on the circ pump test, and it looked good to us. We just lost comm because of the configuration that we were in with the attitude and antenna blockage. We were wondering if you had received message 158 okay, and if it used a lot of extra teleprinter paper. Okay, we copy that, thanks. Columbia, Houston, Brewster, we don't have any data coming down because we're in TDRS mode, and we were just wondering if you are still PTC. Roger, Brewster, we want you to verify that you are in PTC. Roger, Brewster, we were wondering if you're still in passive thermal control. Thanks, we copy that, 1201. That's affirmative, Brewster. If PTC is going, we should get it okay. Roger, so we should acquire you TDRS at 12:35. Columbia, this is Houston. We're 30 seconds LOS. We'll talk to you air to ground 1 through TDRS at 12 plus 35. Any problems with that, we'll get you through Ascension at 13:04. Columbia, this is Houston, with you through TDRS for 50 minutes. Columbia, this is Houston, with you through TDRS for 50 minutes.
We're reading you 5 by, Mary. How us?
Got you loud and clear, Brewster. You got anything for us?
No. We're just waiting around.
Okay, well, we got a special message for you.
Oh, boy.
Sono molto soddisfatto e molto entusiasta per questa nuova impresa.
I am very satisfied and excited about this new space adventure. There are more and more wonderful achievements which are preparing for future progress. It is very important that we follow this path. It is very important that we pursue our U.S.-European collaboration, because this represents a commitment to develop new initiatives in collaboration. I think it is very important, too, for Italy to be present in this collaboration with a first-class contribution, either in the technological, scientific, or industrial fields. This will encourage our country to follow this direction to the advantage of everyone.
In space, we have an unprecedented and historical opportunity for the search of the unknown. Indeed, there are no limits to the accumulation of our knowledge. Therefore, I welcome this opportunity to stress our commitment to the successful cooperation and the US-European Space Lab. We in Europe are glad to work together in this great endeavor across the Atlantic with our American friends. This challenge creates an opportunity for a modern and active industrial enterprises like Fokker and our brightest scientists. I am glad and proud that firms and scientists from my country, the Netherlands, are among those responding to this challenge. In fact, two scientists, one from the United States of America and one from Europe, which cooperate during the present Space Shuttle flight. They set an example of working together in the interest of all.
La coopération de la Belgique à Space Lab présente deux types d'intérêts pour la Belgique. Des intérêts industriels et des intérêts scientifiques.
The cooperation of Belgium with the Space Lab presents two types of interests for Belgium: industrial interests and scientific interests. At the industrial level, this will allow Belgian research institutes to start experiments that are impossible to carry out on the Earth. In this respect, the Space Lab cooperation opens new possibilities that we should pursue. Beyond this scientific interest, Belgian industries, which have the technological capabilities and which comply with the quality requirements for airspace equipment, have the opportunity to demonstrate their know-how by entering into a partnership with ESA first and later with NASA. For a nation such as Belgium, this opens unique opportunities and allows our industries and our scientists to confirm their capabilities. This is why we enthusiastically support such truly multilateral cooperation, which allows each country involved to promote its industrial capabilities.
De valoriser ses capacités industrielles.
Der erfolgreiche letzte Start des Space Shuttles ist ein gewaltiger Fortschritt. Das Weltraumlaboratorium der Europäischen Weltraumorganisation wird dadurch in den
The latest mission of the Space Shuttle was a tremendous step forward. The ESA Space Lab could be sent into space, thanks to the American shuttle. Science will gain very significant knowledge from that mission. I would like to stress the Austrian contribution to it. The windows in their frames were manufactured in Austria. One of the senior project coordinators was Austrian. 3 experiments were designed by Austrian scientists. I am very pleased with this close cooperation with the United States. Let's hope it will serve technology and technological progress. We did our best to make Austria participate in that project, and I am proud of it.
War dabei und das erfüllt mich mit Stolz.
Well, this is an exciting week for Canadians in space. The return of the Space Lab 1 and the Columbia this week. And also in Canada, the nomination of our 6 astronauts who will be working closely with NASA through our National Research Council and who will in fact be participating, 2 of them will be participating in space missions in 1985 and 1986. Well, cooperation is the name of the game internationally. Canada's relationship with NASA goes back over 20 years. And most of us are familiar, of course, with the Canadarm, that very important robotic arm, which has been so helpful on many of the NASA missions and will continue to be so. But in addition, we have relationships with our European space partners as well through the European Space Agency. And of course, Space Lab 1 is very much part of that agency's ambitions that have now been realized in their space exploration. The space contribution for Canada is a very important one on the industrial side, quite apart from the excitement that space generates among the general public. there are major industrial spin-offs that are taking place here in Canada, and of course very much so in the United States and European nations. And we're anxious, we have been anxious, we've cooperated, and we will continue to cooperate with our partners internationally. If there was ever an area where joint international cooperation is important, it has to be in the area of space, which is the future for mankind. And with this particular space mission, Space Lab 1, I'm pleased to say that even there, Canada has participated. The space adaptation experiment being conducted is one designed by Canadians, and in fact, we have 2 Canadian experts in place in Houston who are monitoring the results of that experiment. So again, cooperation, and we look forward to much more of it.
Columbia, this is Houston, standing by for TV.
Okay, well, we're all on the middeck here and ready to go, over.
Okay, we copy. Here it comes.
Houston, Columbia, over.
Columbia, this is Houston. Good to see you guys. You look good.
We're delighted to be here, and we certainly appreciate the messages from the various heads of state and ministers of those countries. I think it is important that we cooperate internationally, and not only in space, but everywhere else. And we're anxiously awaiting to get back to the Earth so we can see just exactly what scientific and technical accomplishments have been achieved and report them. It's been an exciting 10 days, and we think we've learned a whole lot about how to live, operate, and work in space in this delightful environment. Not only just a little bit, but 24 hours a day for 10 days straight. And we think that we've accomplished about what we set out to do, learned about what humans could do in space in the Columbia and in the Space Lab. And both vehicles have performed in a truly outstanding manner. I can only say that the crew that I'm associated with, I'm so proud of them. I can't believe it because they have truly performed, each and every one of them, in every way possible, just beautifully. And I think we're going to be very pleased with the results of this mission when we start analyzing all the data.
Thanks, John. We copy that. And Columbia, Houston, we sure do concur with everything you just said, and we're ready to get back on the timeline now.
Okay, we'll see you all later.
And we finished our TV take. And Columbia, Houston, we're ready for handover briefing whenever you guys are ready.
Okay, Mary, we'll be right with you. Mary, we're ready to copy and go ahead.
Okay, Brewster, stand by for a second.
Okay.
And Columbia, Houston, we got a question for Owen.
Go ahead, Mary.
Roger, we wanted to get some verification that you had done 2 steps in the module, which is IECM control, high rate on and off, item 11 and 12. Over.
No, I have not done that yet. Where is that in the PCAP?
Brewster, that's not in the PCAP. It was in on a teleprinter message 148 alpha.
Okay, I'll have to go check the message because I have not done the IECM step, and is there a big hurry on it, or shall I finish the handover briefing here and go take care of it?
Negative, Owen. Just do that before deactivation, please.
Go.
Okay, for the handover, first of all, I would like to tell you that you're looking at good weather at Eddy for a 161 TIG with a Rev 162 landing. The forecast is 25,000 broken, 12,000 scattered, 7+, variable winds at about 5 miles an hour. And TK Gwynn and George drove the length of Eddy 17, and it looks as good as it's ever been. There's no water on the lake bed. 1, 5, and 2, 3 can be used if they have to. Over.
Okay, that sounds great.
We have some changes to the Space Lab deactivation procedures. If you have those books available, we'll stand by until you say you're ready to copy.
Give us just a moment, Mary. It's not quite ready to copy it.
Okay, we'll stand by.
Okay, Mary, we've moved from the mid-deck back to the Space Lab, and we're ready to copy the deac changes.
Okay, here they come. First of all, on page 2-4, block 1.
And?
The first 4 items in that block will be done by INCO. And secondly, in that same block, the VFI is already in descent transition due to the circ plumb test, so you can delete that step there. We want to remind you to power down experiment number 11. It was left on longer than planned, so we could use those accelerometers, and we'd like you to go ahead and deactivate it any time before Space Lab deactivation, and that would be procedure on page 11 Echo-2 of the payload operating procedures. Over.
Okay, page 11 of Echo-2.
That's affirmative. And one other thing, we would like you to do a manual crash of the ECOS so we can get a dump to the MMU. This would be in your activation-deactivation procedure on page 2-7 in block 5. And block 5 is on page 2-6.
Have a time for that, or when?
It'd be occurring at a PET of 1 + 10, and it'd be the first, add a step ahead, and it would be the first step in that block 5 of DDU deactivation. We're on the experimental DDU, first checking that your computer select was experiment. You would command WCM blank 1639er blank Fox 40, and then enter that. And you wouldn't have to do any ECOS recovery because it's powered down right after that. And Space Lab, this is Houston, standing by for a readback. Go ahead.
We're standing by, Mary, and we'd like to get the last entry, Fox what?
Fox 40, enter.
Okay, I understand you want us to crash the ECOS by using one of the Space Lab computers, or Space Lab DDSs, and it's a command, right core memory, 1639, Fox 40, enter.
Readback's correct, and the only effect that will have on the rest of your deactivation procedures is on block 11 of page 2-10, step 1 and step 3 of block 11 will not have any effect. You can do them or not as you, whatever you wish to do, but the first step, the item 17, if you do that, you're likely to get a link error message. Over. And Columbia, this is Houston with a note on your Freon coolant loop deucer change.
Go ahead, over.
The Orbiter Freon Coolant Loop 2 payload heat exchanger flow deucer has shifted about 500 pounds per hour down, and Brewster picked that up and passed the test earlier. And we just wanted you to know that we have TIMBU'd that to inhibit the FDA, and prior to Space Lab deactivation, the Freon loop flow proportioning valve from the payload position to the interchanger position.
Okay, that's part of the normal deact anyway, is to go back to interchanger, right?
That's affirmative, and you would have gotten an alarm, but now with the TIMBU you won't.
Okay, good show.
One One last thing for Columbia, and we'll hand you over to CIC for a few more Space Lab deactivation additions. But this is on your entry weather block update. We got to give you 2 orbits because we're getting the message up to you a little late. And let me know when you're ready to copy. Over.
I guess this PTC is not doing too good, over, in terms of antennas.
Well, once every 6 or 7 minutes, you're going to fall out.
Houston, Columbia, do you read, over?
Columbia, Houston, read you loud and clear.